So today in this lecture, I'm going to talk about orienting and its control. I know the program has a slightly different title, but I've decided this is the topic. It covers pretty much the same territory as I had imagined, but a little bit less on Treisman's glue. We covered that a little bit the other day. There will be a little bit of repetition in some of the slides from what you just saw before, but as I noted, repetition is good for memory. This is a bit of an outline of what I'm going to cover. The early studies, we've talked a little bit about them, so I'm going to zip through that pretty quickly. We're going to talk about specifically about modes of orienting. One of the topics that I've been very interested in and where I think I disagree a little bit with the field is on how important the difference between endogenous and exogenous control of covert orienting is. And then we're going to talk about the paper by Janitas, 1981, at some length. And I'm going to end with a brief discussion of the Fulk, Remington, and Johnston experiment from 1992 that is a sort of landmark. And it also is a paper that covers topics that students here are very interested in. I'm not going to spend as much time on that, but partly that's because the lab that you did yesterday was almost a direct replication of Fulk, Remington, and Johnston. So you know a lot about how that experiment works. I'll focus more on the results. So orienting is one of the three networks of attention that we're going to talk about at some length on Monday, and which were covered in my short little article that we read when we were talking about mental chronometry. And so it's one of the three networks. But the way it's measured in the attention network test is a little bit simplistic. Posner himself inferred that orienting entails engaging attention, disengaging attention, and moving attention. And he proposed three different neural circuits were responsible for each of these, we'll call it sub-mental operations of orienting. And yet in the attention network test, there's just one subtraction score that we're supposed to use to measure orienting. So what we'll see today is other things. As I noted earlier, here are a bunch of papers Posner presented at Psychonomics, where he launched what now everyone calls the Posner queuing paradigm. This is a printout. I got this out of my files of things. I don't throw anything away, so I have everything that I have ever received. Posner gave a talk in 1975. Attending to a position in space. This is actually what led to Posner, Snyder, and Davidson's paper. And I think compared to most contemporary scientists, especially me, Posner was exceptionally organized. So he never went to a meeting if he didn't have a written version of the paper that he could give people. So this is kind of like the written version of his paper. Now, it might have had a lot of words in it, but it would have had all of his slides. And it has some words. So I pretty much have as many of those as I could find. These are the two papers. I'm not going to talk more about them. But I do want to illustrate the paradigm, even though you probably all are a bit familiar with it. Now, in the example I'm going to show now for endogenous orienting, I'm going to ask you to report whether a line presented in one of these two boxes is a horizontal or vertical line. I'm doing that kind of to make your task harder. But keep in mind that in most of Posner's experiments, the task was to press a button when you see the stimulus appear, and on some trials there was no stimulus. So this is a discrimination task and not a simple detection task. So the trial starts with something that tells the participant the likely location. In Posner's paradigm, as we'll see, it's almost always an 80-20 cue. So this is telling the participant that the target is 80% likely to occur on the right and only 20% likely to occur on the left. I have two different possible cues here. It could be the verbal word auditorily spoken to the participant, right or left, already, very much like I did in my 1994 experiment with Pontifract, or it could be an arrow at fixation, which we now know is not necessarily the best endogenous cue. So you get a cue, and then there's a target. Is that horizontal or vertical? And were you looking at that box or attending it? I'm not, I can't know because I don't have an eye monitor for you. And we already said that the conclusion Posner reached from very many experiments that he reported in his 1980 Posner-Snyder-Davidson paper was this metaphor. We don't need to go into that any further. In the other 1980 paper, while it covered both endo and exo orienting, it focused more on exo orienting, and I just want to illustrate how that paradigm works. So the participant, again, is looking at the fixation. One of the peripheral boxes is going to brighten. If it's pure exogenous orienting, it shouldn't have any meaning, because if the brightening tells you where the target is likely to occur, you will use that information to voluntarily attend, and then we have essentially two kinds of orienting conflated or confounded. So, but we're going to do the same thing. There'll be a cue and then a target. Did you get that? I don't know if I can go backwards. We'll do another trial. Anyway, there was a valid trial and an invalid trial there. One there was a horizontal, one there was, well, I'm not sure what they were. Doesn't really matter. The question was, or the methodology entails, a peripheral event happens, increasing the brightness of the square marker where the target might occur is sort of atypical peripheral cue, but there are many other ones. And if we go back to my 2x2 matrix, what we're going to be talking about in this lecture is the the covert orienting of attention, whether it's under endogenous or exogenous control. And this is a picture I created that illustrates the two paradigms. In Posner's land, they both start with three boxes. You're fixating the middle box. You're not supposed to move your eyes. In many experiments, eye position is monitored, but in some, unfortunately, it isn't monitored. And in those cases, we don't actually know if the orienting that happens is covert or overt. In the exogenous case, there's a peripheral cue or a neutral cue. So I've illustrated that in the second row with a left, right, or this plus sign in the middle. And then the target could be on the left or the right. I've only illustrated the right, left targets in this case. But of course, the target could be on the left or the right. If it was a detection task, there would also be trials with no target to discourage participants from anticipating. So that's a picture of what the exogenous paradigm, pure exogenous paradigm looks like. If it's purely exogenous, the location of the target is unrelated to the location of the cue. So the cues are uninformative. In voluntary orienting, on the other hand, we start the same way, but now an arrow is presented, or some signal in front telling the participant where the target is likely to occur. Exactly as with exogenous orienting, the target is going to occur either on the left or the right. And a typical pattern of results is shown on the bottom. So just to summarize, if you're interested in pure orienting of the endogenous form, there should be a cue that tells the participant where they should attend. It could be because of the probabilities, but there are other ways to encourage the participant to use the cue to voluntarily attend. You could give payoffs that were different for the attended or unattended location. Like you could reward the participant more if they were right for attended than for unattended targets, or you could simply tell them to allocate that much more attention and make everything equal probable. Importantly, if you're exploring endogenous orienting, the cue should not be presented or should not stimulate the pathway of any of the target locations. So that's why cues are central and the targets are in the periphery. If you're looking at exogenous orienting and you want it to be pure, and exogenous orienting has this strange feature where when it's pure, it's also kind of like a distractor paradigm. I'll come to that in a minute. But in pure exogenous orienting, a stimulus is presented in the periphery at a location where a target might occur, but it's completely uninformative about where the target might be presented. So you're presenting something in the periphery, it's going to stimulate a pathway that could be along the input pathway of a target, but it's not a location you would want to attend because it's not more likely to contain the target than any other location where targets could be presented. The reason I said it's a bit weird is because, okay, that cue might capture your attention, but in a way, your goal should be to not attend it. And the fact that you should not attend it does kind of mean that endogenous orienting could be playing a bit of a role, at least something endogenous having to do with, let's say, trying to filter out the cue. Why would you want to attend a peripheral event that doesn't mean anything? So, exogenous orienting is a bit weird. This is just a terminology slide. Whether we're looking at purely endogenous or purely exogenous orienting, the terminology that people tend to use, I think Posner launched this, is when the location of the peripheral cue or indicated by the central cue and the target match, so left, left, or right, right, we refer to those conditions as valid. And when they mismatch, we refer to them as invalid, and then we might have a neutral condition. Some experiments don't have neutral conditions, where the cue, if it were peripheral, we're not in a peripheral location, or some people use cues in both peripheral locations. Or if it was central, it didn't give any information about where the target might be. While this is on, I just want to say that, in my opinion, it's not good practice to refer to the cues as valid or invalid. The target was either validly or invalidly cued, or the trial was an invalid or a valid trial. And the reason is, when a cue is presented, it's a cue, but it doesn't have the status of being valid or invalid until the target's presented. So the cue's identity is I'm a cue. And later we find out whether it was a valid or invalid one because of where we put the target. So I prefer to say it was a validly or invalidly cued target, or it was a valid or invalid trial. But it's not a good idea, I think, to call the cues valid or invalid because they don't have an identity. This is the typical pattern of results. It often is a little different from this. One of the reasons it's often different is that the neutral condition, it's very hard to have a neutral condition that is, we'll call it, believably neutral, especially with exo or peripheral cues. In the attention land, Posner pioneered the idea that we could talk about the separate costs and benefits of cueing. Of course, the cost is how much worse are you in the invalid condition than in the neutral condition. And the benefit is how much better are you in the valid condition than in the neutral condition. But because neutral conditions aren't always trustworthy, some people just talk about the cueing effect, which would be invalid minus valid. So Janitas was an early researcher to be interested in the modes of control of attention that had been highlighted by Posner in his late 70s presentations in psychonomics and in his 1980 papers. In 1981, he published this paper. It was probably presented at another meeting of attention and performance, maybe the one right after mine. So I think my meeting was in 78, so this might have been 1980 meeting. Not 100% sure about that. So he refers to voluntary versus automatic control of the mind's eyes movement, using that metaphor we talked about in the last presentation. And his hypothesis was central and peripheral cues will control attention differently. And he thought, and the title of his paper refers to this difference of control as voluntary versus automatic, or we might say voluntary versus reflexive. He conducted 3 experiments, each of which had a different diagnostic for reinforcing or not this distinction. In one, he manipulated the amount of processing capacity that the participants had available at the time they were doing the task. In another, he actually instructed participants to ignore the cue to see if they could ignore it. The notion, of course, being that if they couldn't ignore it, it was automatic. And then he manipulated the probability of the different types of cues. And the notion here was, if it's completely reflexive, the probability of the cue shouldn't matter, but if it's voluntary, it might matter. I'm going to review the methods of all of his experiments. They're similar. There's a similarity. The subject's task was, is there an L or an R in an array of 8 letters? So centered around a fixation. I think I have this picture of this later. There's an array of letters. One of them is an L or an R. So every trial has a target. But it's not an easy task to perform because you pretty much can't tell if there's an L or an R in the array without looking at the items. He preceded the array by a central cue, which was an arrow at fixation, or a peripheral cue, which actually was an arrow in the periphery, sort of pointing at one of the locations. In the different experiments, he varies this differently, but we'll see that in a minute. So, looks like I have an illustration of this paradigm. You're looking at fixation for a certain amount of time. There's a brief cue presented at fixation, and then an array appears after a brief interval. And that also is brief, according to this slide. And the subject has to say, was there an L or an R? I'm now remembering why this is brief. It didn't have to be brief, and of course it makes the task hard. The reason it's brief is because Janitas didn't have the ability to monitor eye movements. So if you wanted to ensure that the participant at least couldn't inspect the array with an eye movement, because by the time they could move their eyes, there would be nothing on the screen. It turns out that that's not a particularly good strategy. In this study, I don't think it would matter much, but it's not a good strategy because participants may move their eyes anyway. And it's been demonstrated that when participants move their eyes, stuff happens in the nervous system. The receptive fields of neurons in different parts of the brain actually change because of eye movements and this remapping phenomenon. So the execution of the eye movement, even though it can't tell you anything about what was on the screen, because there's nothing on the screen anymore, might affect the information your brain already picked up from the screen in the 25 millisecond presentation. And so it's better to monitor eye movements if you can, essentially. Using this technique of a short duration is a weak strategy. It's certainly better than not using it. In the peripheral case, the sequence is very similar, except that the arrow, instead of being at fixation, was in the periphery, pointing to one of the locations where a letter might occur. So that arrow was in the periphery, pointing at the location of the teeth. So we would call that an invalid trial, or an invalidly cued target, because the target is down here. So that is the R. So experiment 1 shouldn't matter if you absorb the participant's capacity, but if orienting is voluntary, then absorbing the participant's capacity will interfere with the orienting. So the key manipulation here was he gave participants a memory load prior to the trial. So they had to remember either 3, 5, or 7 digits. And then they get the sequence of events, just like I've shown. And then there would be another trial with new digits. I wanted to ask for recall of the digits, of course. And then there would be another trial with 3, 5, or 7 digits and another sequence of events. And he did that with both the reflexive cues, sorry, they're not reflexive yet, with the peripheral cues or with the central cues. So all the participants did all the conditions, but the type of cue, central or peripheral, was manipulated between blocks of trials. Interestingly, whether the cue was in the periphery or whether it was central, it was equally informative. So this methodology, which I should mention I've used in my research with GIAN that we're going to talk about shortly, has costs and benefits, but not the kind Posner was talking about. The benefit is the only difference between the cues is whether they're central or peripheral. They have the same meaning. The cost is the peripheral cues now are hybrid. They're peripheral, so they might attract or capture your attention from being in the periphery and being near the pathway where the letter is going to occur. That might or might not be the target. But they also are ones you might actually want to use. So firstly and importantly, the memory load manipulation mattered. Participants' reaction time and errors on the left-right discrimination increased as they had an increasing load. So the task is not automatic, deciding whether there's an L or an R in the array. The question here is the orienting automatic? And the results were pretty clear-cut. This is the actual data, but I like to just put lines in to just make it clear what's going on here. The green line represents the central cues, and the red line represents the peripheral cues. And what we're plotting on the y-axis is not reaction time, but actually the cueing effect. So this is the reaction time on invalid trials minus the reaction time on valid trials. And they're very big effects, partly because this task is quite hard, because it's an 8-item search task for an L or R. And so, when there's a relatively low load, both tasks are showing very substantial queuing effect. So there's a big either benefit or cost cost plus benefit. The queuing effect here is cost plus benefits because it's invalid minus valid. Importantly, the degree to which the central arrow captures attention is unaffected by the memory load at all. So the red line is flat. Well, the red line is flat. The data that I plotted with the flat line are pretty flat, or not varying significantly as a function of memory load. But the green line, which represents the data from the central arrow condition, show a very dramatic decline of the queuing effect as the memory load increases, as if it becomes harder and harder to use the central arrow to attend in the periphery. The more items you're holding in one memory. So experiment 1 has a very clear finding. In experiment 2, he's using 2 conditions. He's telling participants to attend to the cue or to ignore the cue. As before, all the factors are manipulated within subject, except the type of cue was, the type of cue as well, but the type of cue was manipulated between blocks. And he made the cues uninformative. But they're equally uninformative. So there's 8 items, so 12.5% means the cue has no meaning because 1/8 is 12.5%. So you shouldn't want to attend the queue because it doesn't tell you anything. But in one condition, you're instructed to ignore it, and in another condition, you're instructed to attend it. And the question is, will essentially the experimenter's instruction matter? And Janitas reasoned that if the orienting effect were purely automatic or reflexive, it shouldn't matter what the instruction is. But if the orienting effect is volitional, it might matter. Maybe it should matter. So these are the data, but we're going to skip over them and plot them. When participants were told to attend to the cues, whether they were central or peripheral, they could do it. I'll just mention that there were two durations in this. No, sorry, that's the next experiment. And the effects are quite similar for the central and peripheral cues. However, when they were instructed to ignore the cues, they had no trouble doing this when the cues were central. So a central arrow that they were told to ignore, they could do. But they couldn't ignore the peripheral cues. In fact, the red dashed line is pretty much the same as the red solid line when they were told to attend it. So the peripheral cue is capturing their attention whether they want it to or not. The central cue they use when they are told to, and they don't have to use when they don't want to, or when they're told not to. There's a possible discrepancy between the results here and something I said in my previous lecture. Anybody have an idea what it is? So look at the green line on the right. We have an uninformative peripheral cue. Now, admittedly, you're told to ignore it, and you can. Sorry, you have an uninformative central arrow cue. You're told to ignore it, and you can. In Shepard, Finley, and hockey, participants were presented with uninformative central arrows, and they did show orienting to it. Now, they weren't instructed to ignore it, so maybe that's what's going on, but there was no reason to attend to it because it didn't mean anything. So, but maybe the instruction matters. In the third experiment, Janitas manipulated two things. One was whether the peripheral cues were less likely and the central cues were more likely. So this is not about the cue's informativeness, it's about the probability of getting the cue. So either you're in a block of trials where there's a lot of central arrow cues and hardly any peripheral arrow cues, or there's a lot of peripheral cues and hardly any central cues. He made the cues informative again, like they were in experiment 1, so you would want to use both cues if you could. And he had two intervals between the cue and the target array appearing. So either a very short interval of 25 milliseconds or a longer interval of 100. Frankly, they're both very short, 100 milliseconds to 10 seconds. So we're only looking at the effect of the cue really right after the cue had been presented. And here are their data. And then I like to superimpose lines on this so it's a little easier to talk about. So first we'll talk about the data from the peripheral cue position. These are the red lines. On the x-axis is simply the duration of, the interval between the cue and the target. And the difference between the lines is the probability. The difference between the panels is the probability. So in this panel, on the left, central cues were likely and peripheral cues were unlikely. And in the right panel, the probability was reversed. The difference between the lines is the cueing effect. Because one is valid and the other is invalid. The queuing effects are quite large, like as in E1, they're like in the 300 millisecond range. But more or less, the queuing is unaffected by the probability of getting a peripheral queue, because the two side patterns are very similar. But the data are quite different when we look at the central queues. When central queues are likely, there's robust queuing, regardless of the interval. But when peripheral queues are likely, the pattern changes a lot. Now, I'm not saying we can completely explain the way the pattern is changing, but the fact that it's changing because of the probability of a queue is telling us that it's not completely automatic. And what we're seeing is that at the shortest interval, the participants haven't quite used the queue. By the long interval, they're able to use it. This is when the queue is improbable. So we have three converging methods or diagnostics for automaticity. Was the queuing affected by load? Endogenous queuing was, exogenous queuing wasn't. Can you ignore it? You can ignore central queues, but you can't ignore the peripheral queues. And is it affected by the probability of getting a central or peripheral queue? Yes, if it's central queue, no, if it's peripheral. In other experiments that Janitas had conducted, but not reported in this paper, he also demonstrated that the time course of getting attention to the location indicated by a central or peripheral queue was quite different. People were much slower to orient their attention to the location signaled by a central queue than they were to get their attention to the location indicated by a peripheral queue. So we could say that endogenous orienting is slower than exogenous orienting. Janitas and most other scientists refer to this difference as one that I like to think of as about transportation. It's like two different ways of getting attention to a location in space. You know, there's the fast and automatic way with the peripheral cue, and there's the slow and voluntary way with central cues. But they generally thought that exactly the same beam was being moved. Sorry for using the metaphor, but attentional resources. I didn't dispute this, but my graduate student, Brian, who did this very clever experiment where he was asking, is Posner's beam the same as Treisman's blue? And I'll be going through this experiment a little bit, I hope to make it clear, did find that there was a pretty big difference that seemed very important between not the control mechanism, but the effect that orienting attention endogenously or exogenously had on performance dealing with the target. And the effect that attention has on target processing is a little bit more about, so what type of beam is it, rather than it being about what type of control is it. So we varied control, and our question was, will the orienting in a Posner queuing paradigm, which was going to be either a central queue or a peripheral queue, will that interact with, we'll call Treisman's feature versus conjunction type tasks? So I've illustrated here. Now, we didn't really present a search task. The participant was presented with a cue, could be an arrow fixation or a peripheral brightening, and they were presented with two letters, and they simply had to say whether there was an R present amongst the two letters. We had two sets of letters that the letters that were presented could be drawn from. The set could be RPV or they could be RPQ. Now, in Treisman's feature integration theory, she argues that the features of a stimulus require attention to be integrated. And what we were essentially asking was whether that attention that she was referring to in her theory, the attention that glues things into objects, glues the free-floating features into objects, was the attention that's oriented exogenously or endogenously, or just both. And it could have been neither, actually. It could have been that the kind of attention Driesman was talking about was different from the kind of attention Posner was exploring with his cueing paradigm. So what we found was it was one and not the other, but we could have found it was both, and we could have found it was neither. So there were a lot of possible results we could have obtained. But in any event, because the R has features of both P and Q, and the R does not have both the features of P and D, you could tell if there were an R present by the presence of this feature, slanted line, when you were in this set. But you couldn't tell if an R was present simply by this feature when you were in this set, because the Q has exactly that feature. So we essentially were using stimuli that could afford or enable illusory conjunctions. In other words, if you presented these two stimuli outside the attention that Driesman thought glued features together, you could have the illusory conjunction of an R. But if you have P and D presented, you can't have the illusory conjunction of R because you don't have all the features to make an R. So if we imagine that we have a feature task and we have a conjunction task, and we have a Q, we were imagining that attention could affect performance on feature and conjunction tasks, because attention affects even the detection of the stimuli. But it ought to affect the conjunction task more if it's important for feature integration. So that was the logic of our experiment, was there might be an interaction. And that's exactly what we found in 3 different experiments. When we found this interaction, which was a greater effect of attention, valid versus invalid, but only with, on the conjunction trials, but not the feature trials, but only with exogenous cues. So this was the first demonstration in the literature that the effect of orienting attention endogenously versus exogenously on processing might be different. By itself, it wasn't earth-shattering. I have to say I was very pleased when Sternberg wrote me and was very happy to see our use of, even though we didn't talk about it, our use of additive factors logic, because the additivity here implies that Posner's beam, when it's endogenously controlled, has nothing to do with Driesman's glue, which is what you need to integrate features. Because of that additivity, they're operating at different stages of processing. And here, because of the interaction, they have to be operating at the same stage of processing. They could also be operating at other ones, but there has to be overlap. Earlier, I had an anomalous finding that I'm going to talk about a little bit. So this is actually a 1980 paper, but it wasn't really about the endo-exo distinction. It was just about our failure to find an effective orienting for stimuli that were unlikely. And I followed this up later and found that if you have an endogenous cue that tells the, central arrow cue and endogenous cue that tells the participant where a target is likely to occur. But there are 2 targets. And one of the possible targets is a likely event, and the other possible target is unlikely. And in different experiments, I have different possible targets, but let's say maybe there's 4 dots on the screen and they can get bigger or smaller. And you have to decide